Today we're going to be going over some pretty exciting things, I think. It's one of the very, very popular tools, one of the most popular tools that Grasshopper has, I think, that people really love to use, and it's the idea of attractors. So attractor points or magnets or whatever you want to call them, there are a bunch of different ways of doing it. But basically it's a way of taking a point and modifying geometry based on its orientation or proximity to that point. If you don't know what I mean, you will in a second. So what we're going to do here is use a grid very similar to the one we've already started. So you can stick with the square grid, but I wanted to include it in this Grasshopper file, particularly because it has to do with patterning in many cases. So I would suggest make sure you group the stuff that we did in class on Tuesday and turn it off. So select it all, middle mouse click button, and turn it off. Now we're starting fresh just below it, and we're going to do another square grid. If you liked the square grid that you had, feel free to grab that component from this group and just bring it down. And of course I'd suggest turn it on again. Alright, so what we're going to do basically is just start off very simple and very abstract. Okay, I'm going to show you how to do an attractor point. Then use a line as a list of attractor points that will modify it. And then we're going to look at what that means for three-dimensional applications. Then the very, very cool part that I really hope we can get to here tonight is we are actually going to build the Herzog and de Meuron central signal box building facade. You can't really see it all that well in this image, but this kind of gives you a good... Well, it looks like this from the side. Okay, so it's basic. This one I don't think is necessarily an attractor point per se, but it does have an attractor-esque sort of morphologic sequence to it, where a particular point in the facade is open, and then on the ends it flattens out and closes. If that makes any sense, it flattens out over here. So I'll show you that in Grasshopper. This is another very cool image of it. So let's get started with that. And the first thing we're going to do here is on the square grid, we're going to establish at every point a rectangle. So go up to Curve and Primitive and Rectangle. And basically just take the points list and plug it into the points input or plane input of the rectangle itself, and you'll see that it places a rectangle at every single one of the points, and what we're left to do is establish how big each of those rectangles should be. So I could put a slider on it, and so let me put a slider that goes from 0, I don't know how big this is, so I'll just make it from 0 to 2.5 to 10, and I'm going to make sure that they're square, so I'll put it into the X and the Y. And here's something that's interesting, and while it doesn't relate to attractor points, I want to make a point of showing you. The original position of the rectangle, if I delete this, you guys should stop for just a moment and take a look. If I delete this, the rectangle is centered on the point. With it there, it is not centered on the point, it grows from the point in the X and Y direction, positively. What we'll need to do, if we're going to establish the X and the Y to be centered, we need to create it as a domain, which is very, very important to know the difference of. So a domain under Math Domain, Construct Domain, remember we did this on Tuesday. We can plug in the same value as a positive and then the same value as a negative. Let's see, did I do an expression? Yeah, I did. We could do the same value as a positive and then create one to be a negative that's going to go in the bottom side, and that can be done two ways. It can be done using operators and negative, and then you plug it in. Whoops. and then this plugs into both. Now you see they're centered. Or it can be done without the negative component. This is your first time, I think, that we used expressions. So if I go here and I right-click on the domain end input, and I go to expression, whoops, it's got to be over here, and I go to expression, this is going to take your typical kind of mathematical calculator syntax and do formulas for you. So if my input needs to be negative, I type negative, and then the algebraic variable of x. And that way, any number that comes in is going to be translated into a negative number. So it's up to you whether or not you like using expressions or you like to have the node sitting there in space. Personally, I don't mind a lot of nodes as long as I can visually see what it is. That's why I use the panels that say 1. So I'm not generally a fan of using expressions. I just want you to know you can do it. So from there, we have just a couple of things that we're going to need to do. Let me see how we're doing on time here. Okay. All right. Well, I think I should probably close this thought with that, just the introduction of expressions, and then I'll do another video that goes through the entire sequence of establishing your attractor point. So, any questions so far on that? Rectangle is found under curve primitive. This one is vector grid. And domain is under math domain. Not meth. I cracked myself up. All right, let's move on to the next one.